Alright, so just a quick introduction what we have in the optics lab. This is a 2-inch by 4-inch, basically a breadboard. It's the basis for all the lab we do. We put everything on top of this breadboard. These holes are 1 inch apart compared to the 25 millimeters apart. If you go to the other side of the pond, we're still using inches predominantly in optics. So 1 inch apart, and these screws are so-called 1/4 inch 20 screws. The mechanical engineering students may need no introduction, but the 1/4 inch means the diameter of the screw is 1/4 inch, and 20 is 20 turns per inch. If you turn the screw 20 times, the screw moves forward by 1 inch. Let's see, do we have the box? Everything's here. All the big screws are 1/4 inch 20. And there's also some nuts and some washers you can use to secure components on top of it. This one here is an optical rail. The purpose of this is to do a one-dimensional setup. You can set everything up along the rail, and the cross-section of the rail is like a tail of a dough. So it's a dough-tail rail, and you can slide a rail carrier on top of it, secure it, so it'll be staying here, and you can read the positions pretty easily. You can set up a lamp, maybe a couple lenses, and put a screen just to find out where the image shows up, if it's actually consistent to what we're supposed to get from theory. Okay, just a desk lamp. Make sure you check that. And a little tool rack. It's got the 4 tools. These are the Allen wrenches. The biggest one, definitely for the 1/4 inch 20. Socketed bolts, so you can tighten it with large enough torque, or you can try to tighten it down real quickly just by spinning it. And you have a little jeweler's screwdriver for adjusting finer optics. There's also one of these, I can't remember which exact one, is for a smaller size. I think it's 832, the smaller size screw. They look really different. You won't be able to mix them together. So that's a platform. If you open the drawer, well, it looks like at least somebody did a good job putting this back together. That was maybe optical communication or fiber students. So let's start with basically the carrier. This is the real carrier, and you can see the side of this is half of this is actually dovetail that actually mates with that optical light reel. So this is a 1 inch one. It says 13 millimeters, and we got 26. This is a 2 inch wide. You can put something a little heavier on top of it, and the way to put it on is to just take one of this and just kind of slide it in. You don't always have to slide from one side. If you loosen plenty times, you can put it on like this. But trust me, it doesn't really fit exactly perfectly. There's a little thing here. This is a little plastic piece. It doesn't really belong here. I think it does belong to this carrier, but it's not really exactly compatible with the rail. So for this little thing, the rail should actually have a groove for this little plastic piece to fit in to get some additional stability. But this is just a generic reel. It doesn't have that feature, so make sure you tighten enough so that the little plastic doesn't make the thing wobble. So just make a few turns. That's good enough. So the 2 inch one, basically, if you put something heavy on it, you can use a 2 inch one. If you have any questions, just let me know. Okay, so let's go ahead and look at a few more things here. Okay. Well, you have a post and a post holder, and the post is 1/2 inch diameter. We have some smaller ones, but we typically don't use them. This is the half inch diameter post, and that's the post holder. It holds the post, and you can tighten it with the side screw here. And there's also a little there's a socket here. You can tighten it really tight if you want, but typically, yeah, you can just hand tighten them, especially for the earlier labs. But for microsun diffractometer, if you really want to tighten it down, you can use an Allen key to tighten it. And these two sides, basically these two holes, they're both 1/4" 20 holes. So you can certainly secure these things against other pieces of optics. Take for example, if you want to secure this to the breadboard, and both sides are actually threaded holes, what kind of screw do you use?
The thing without
the thing without the head, or is there a mechanical name for mechanical linear side? It's a set screw, right? It's a set screw. So let's go and find a set screw. So here's a set screw, and to tighten it, it's actually pretty easy. You just use friction. See that? There's actually a little socket here. I would prefer the socket pointing up, because in case the thing gets stuck, you can still get a socket wrench, just pull it in and try to loosen it. If the socket is pointing down into the breadboard, there's no way to access that thing once it gets stuck. So it's considered bad. So the socket should point up if you have an access to it. But if you don't have access either way, it doesn't really matter. Just pray it doesn't get stuck. So now you just turn it a couple times and put it on the breadboard and start turning. Because the more turns you have on either side, the more friction it has. And the other side will have less friction, and it will make more turns through that side. And it kind of just balances out. If you don't trust me, you can take a meter stick with your 2 fingers supporting it, try to bring your fingers close and close together, and you always end up with the center of the meter stick. So just kind of turn it a couple times. This is tight enough, but there's no way to move it slightly, kind of nudge it slightly, so there's no way to move it once it's set up. And you can put the this side in and just tighten it. And on top you can put something else, say a platform or something else that actually uses this. And the other end is again 832. It's a different thread, but they're so different. You won't be able to mix the two. This is so small, that's pretty big. Yeah. So post and post holders. Maybe another type of post holder right here compared to the first one. This one has a little pedestal and it's also magnetized. So it's very easy to reposition, and then you can tighten it down with this little clamp. This is a pedestal post holder clamp, and you just basically point it down, and if I just try to move it, you can hear that, right? It was actually not touching the breadboard on this side. That's actually in contact with the pedestal, and this side is touching. So if you tighten it down, it will be grabbing down the pedestal. The pedestal won't be able to move. So this one is more useful for, say, if you want to reposition this just a little bit, it's a little off. It's not really on these 1-inch matrix. You can do that. Just take one of the 1/4" 20 screws. Just put it through this slot. Let's find a good. Okay, this hole is good distance. Basically, just tighten this 1/4" 20 into it with the Allen wrench, and you'll be able to secure the thing. Similarly to the other version, without the pedestal. Just turns a few times. If it actually gets stuck, try to go back and forth. If it actually still gets stuck, and remove the bolt and look at the thread. Maybe the thread is messed up. If it has even one part of the thread is messed up, you have to toss it. Otherwise, you're going to mess up the thread on the breadboard, which is not replaceable. So, just a couple turns, just add it with maybe a 1/4 turn, getting it really tight, and this is not going anywhere. Any questions? Okay. Good. So let's go to the next one maybe. Yeah, this one we don't really use anymore, but it's still in the drawer. You can still use it. This is a plastic version of the stainless steel. So I don't really like this too much, but if you're running out of these regular posts, you can use these plastic ones. They're all black. The sizes, we have various sizes. We have a 1-inch. We got 2 inches, and the most frequently used 3-inch. We only have a few of these 4 inches. and they're matched up with these holders. So 4-inch holder, 4-inch post will make a pretty good T in here, because you can use the entire range up and down the vertical freedom to adjust your height, the height of the optics. So let's take this one out. And let's see, what else do we have here? Different post holders. The 1-inch and 2-inch, and there's 3 and 4 inches. So these are the basic components. And let's take a look at this one here. This one is sometimes referred to as a guillotine. You can always call this a V clamp because it actually shows a little V shape here. So it shows a V shape here, and it's very easy to put a lens right inside or something that's circular inside and try to push down on the top piece to secure the optics inside. So it's kind of flexible mount. You can put larger optics in it, you can put smaller ones in it, you can put optics that's already mounted on the tube inside. So it's kind of flexible. We can also hold a laser tube with 2 of these, and there's a lot of options we can use. So essentially just loosen this screw here, put the optics in, and push it down. And this part right here is spring loaded. So try to push it down, it will actually press against the optics to make it even further tight, and just tighten this. That would be a good setup. And this side, the set screw, and you can only use set screw because this is a V here. There's newer ones that actually have flat surface right here, and it's also counter sunk. So you can drop in a screw with a head, but these versions you can only use set screws. You just take a post, and just kind of tighten these 2 together, and you can just put it on the post holder. Just hold whatever you want to hold. So typically setting things up will be easy with this. You can just pull, get things out. Okay, so any questions so far? All right, so I'll put all this back.